So, what is science? The short answer to the question, what is science, is that science is a method of observing and describing the world, then recording those observations in the form of data that can be used to make predictions and to understand how the world works. From this perspective, anyone who uses these skills is a scientist. The longer answer is that science means creating hypotheses about the way the world works, then testing those hypotheses in observable and repeatable ways. When a hypothesis has been confirmed over and over again multiple times, it can enter into the realm of a bona fide scientific theory. One key principle of a scientific theory is that it must have a falsifiable premise. What does that mean? This means that there must be some way to prove that the theory is incorrect. So how does that work? Suppose you're trying to tell me that the Earth is flat. I tell you that it's a sphere and give you photos from satellites showing it to be round. You then tell me that those photos were faked. So I show you videos of ships disappearing over the horizon. Again, without any evidence to back your claim, you tell me that those videos were faked as well. For every piece of evidence I present to you that the Earth is not flat, you deny my claim without presenting any counter evidence at all. In other words, there's no amount of evidence that would convince you. This means that your theory that the Earth is flat is a non-falsifiable premise because there's no way for me to prove it wrong. When conducting experiments, it's important that the experimental hypothesis be constructed in such a way that it can be proven wrong given the right evidence. That's why the results of all scientific experiments are only tentative. Scientists gather data in support of their hypothesis, but they're always willing to examine credible evidence that might disprove it. In fact, the peer review process required for publication in most scientific journals actually requires that the peer review committee attempt to disprove the experiment's results prior to publication. That's why when you're looking at research, it's important to see if the research was subjected to peer review prior to publication. If an idea or hypothesis correctly predicts how something will behave, and the results are repeatable, we call it a theory. If a hypothesis explains all the data or evidence that has been collected on a particular topic, we also call that a theory. That's why we refer to the theory of evolution and the theory of gravity. Both of these theories are the best explanation that fits all the data. This doesn't mean that they're written in stone and can never be changed. What it does mean is that they can be changed by credible scientific evidence. So what do we mean by credible evidence? Credible evidence usually has one or more of the following 5 criteria. 1. It must be observable. In other words, there must be something there that everyone can see for themselves. 2. It must be measurable in some way. 3. It must be quantifiable. 4. It must be predictable and that the same experiment done in the same way should yield similar results. And finally, 5. It must be repeatable for the same reasons. Science doesn't always line up with what people would like to call common sense. For example, when the ancient Greeks discovered that the world was round, it was considered common sense that they were wrong because the world is such a large sphere that it appears flat from the vantage point of a human standing on the ground. It was only as more scientific data came in that we discovered that the world isn't flat, in spite of what the common sense of the time period told us. So what this means is that a certain amount of open-mindedness is required for any scientific experiment to be conducted. That, and a willingness to be open to whatever the science tells you, even if it contradicts your own cherished notions about what you might consider to be common sense.